Hello friends, welcome to this video. This video is a part of YouTube series Data Science and Machine Learning. Those who are interested in becoming a data scientist or those who are already experts in data science and want to extend their knowledge, this YouTube series is for them. In a last video, we have seen a machine learning, the essence of the machine learning. we first take we first did the exercise of finding the hyperplane which will separate out the two classes. That was done by me. That means it was with the human intervention. So I decided, I visualize the data of the two types, the two class types, two class data I observed, and then decided where should be the hyperplane. In another exercise, we have made an algorithm, and algorithm calculated the things from the given two class data and then decided the hyperplane. So this is how the machine learning starts. This was a simple example of finding the hyperplane, but there will be as we move on, as we go to the advanced machine learning, we will see how the optimization works works or used to decide the hyperplane. Fine. So in this video we are going to see quite a bit of programming, and in a last video we have seen that we got one equation which was nothing but the 4y plus 10x minus 27 is equal to 0, right? So let us visualize that, because sometimes in a sometimes in a analysis of the data, or while taking a decision on the hyperplane, or seeing the quality of the data, I think we will have to plot on a graph also. Okay, and then I think if there is a lot of, because when when the manually we generate the data, it could be at 10 points or it could be at 20 points at most. More than that, it is very difficult to have or the simulate the data. But programmatically, I think we can have a data as many as we want. It can go up to 1000, 10,000 points, and even the more points. Okay, so there is no limit on the data which can be simulated by the programming. So it's very important to see the plotting of the line. We will also plot the points and all. In fact, whatever we did in a last video, automatically we will see what that algorithm has done. But for now let us see how to plot the line. And we got a 4y plus 10x minus 27 is equal to 0. So normally, to draw the line, I think we can have a standard equation, the y is equal to mx plus c. So just convert this equation into in this form, and we can easily do that. Let the y be on this side, and all these two terms take on the right hand side. So y is equal to minus 10 by 4x plus 27 by 4. And now this minus 10 by 4 is nothing but the slope, and 27 by 4 is the y-intercept. Okay, so m is equal to minus 10 by 4 and c is equal to 27 by 4. Put this value in a x2 is equal to mx1 plus c, and this is the same as a y is equal to mx plus c. When there are only two variables, I think we can consider the y and x, but I think later on we will find that we will have a more number of input variables, and not not like a problem will be restricted to the only 2 dimensions or the 3 dimensions. So when we go for the higher dimension problem, probably we will need to go for the notations of x2, x1, x2, x3, x4, x5, x6, and so on so forth, right? Right now, don't get confused between these two, whether it is a y is equal to mx plus c or it is x2 is equal to mx1 plus c. Don't get bothered into that. Now m is equal to minus 10 by 4 and c is equal to 27 by 4. These are the constants of the of the of the line. And so let's take a x1. X1 means on the horizontal axis, because the plot will be like this, and then this will be the x-axis and this will be the y-axis, or this will be x1 axis and this will be y-axis. Okay, so here we will x1, that means the horizontal line, from minus 7 to 8 points we will take. You can use a numpy library for that, np arrange, and it will give a array of with the values minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, and not the 8 will not be included into that. Okay, and this one is because of the steps, because we were taking the steps of a 1, starting from the minus 7 to up to 8, but not inclusive of 8. So we got a x1 points on the x-axis or x1 axis, and x2 or the y is calculated as a whatever was the element in the x1. So just pull out that element one by one. So one element x from x1, and these, the operation to be done on this x is m into x and plus c, and we will get the x2 values. Okay, we take a plot matplotlib python library, and just take it as a plt. So plt figure 2, we will see, I mean, what it is. The figure size 8,6, so just the standard initialization, and I think this is the 8 and 6 is nothing but the size it gives. Okay, we will see that. We will not bother about the about much detail about matplot library functions. So now what is our aim is, okay, let's draw a plot scatter 0, 0. Okay, so just to show the origin in a blue, we will show that. Okay, and why it is so, we will see that actually. So plot x1, np0's length of x1 and blue line. So just I think it is a x-axis and y-axis passing through 0, 0. So two lines we are drawing here, and now plot x1, x2. So now this is the real line and this will be in the red. Okay, this is the line we need to plot with these parameters, right? And then x label x1 and x2, the legend x-axis y-axis line you can add, and then title is line is equal to y is equal to mx plus c, m is equal to stm. So just we can format the string to show the title of this line. Okay, so we will get to see the line this way, right? So let me also go to the same program in line draw. Okay, so line draw one. Right, so that is available. This is available in this is going to be available in the GitHub repository, which is a public repository. You know the name and the link of that. I think it was given in the video 10th video. It is available. So we will just run this program, the same program which was on the PPT slide. Let me run this. And we got this one. So let me do this with somewhat here. Okay, so this is the line, and I can keep on changing anything here. Let's say -2, and intercept maybe 1, positive 1. Okay, and let me plot it. Okay, so m is equal to -2. Okay, that is okay, and c is equal to 1, so intercept is 1. Okay, this is the y-axis, this is the x-axis. Okay, this is y-axis, this is 0 0 origin, and from here if you calculate on the y-axis, this red line is intercepting to the y-axis at the point 1, okay, at a distance 1. Yeah, so I think we have got so many lines here. Okay, so we got a mx plus okay, so minus 2.5 and c 6.75. I think this is the line which was derived by our algorithm, okay, and that we tried to plot out here. And we know that we have a data at this position, one type of class data, and another class of data was here. So this was the best line mathematically calculated by our algorithm to separate out the two classes. Okay, so again, I mean, separating is nothing but the classifying also. And how to classify that, we have seen that we have to solve the data point for this hyperline equation on the hyperline equation, and then whatever the value sign, whatever the that equation value sign tells, that will decide whether that point is on this side or that side. Okay, now another just example I plotted, I changed the slope and the y-intercept, and you can see the slope is this, and you can see the 1 to -3, so c was -3, and that's why it has come here. Similarly, you can see the different value, m is equal to 7 and c is equal to 5, so 5 is intercept and it has a higher slope. Okay, it has a somewhat less slope, m is equal to 2 and c is equal to -1, so at the -1 it is intercepting on the y-axis. Okay, so these are the lines, these are the lines we plotted. Okay, so now we will see how to implement the machine learning algorithm. I think that machine learning algorithm we have already seen in the last video. So that algorithm is nothing but this one. Okay, I have just copied here and put that in a comment. We have this file, data classifier underscore 02. It will have a main algorithms, and if it needs some utilities functions, it is in the classifier underscore utils. Okay, so so here the first of all, okay, I think the steps we know that we will have a first the data and all. So let's generate the data of the two classes, and I think as I mentioned earlier, we are going to generate the data not manually but by using a script or by using a program. So this is the function, this is the program, this is the function which will generate the data for us for the two class and with the 2 dimensions. So if you see what are the arguments, so it is returning the class 1 data and the class 2 data here. Okay, this is the function data to class simulation. Okay, data to class simulation, and that's available here, the data to class simulation in this file. Okay, so we will see the values. I think these are the same values up here will come here. So we can I'll just do this one. Okay, so instead of looking at these values, these are the similar to these values. I have not changed or I have not changed the structure of these. So I think in a Python you might be knowing that if already in a function definition, in the function definition itself, if you give us some data, you can give over there, so that while calling that function, even if that arguments are not given, it will take a default values over here from here. Okay, and if we give, while calling, if we give that value will override this value. Okay, so for example, just a small example, like here class underscore 1 is equal to -4 comma -1. Now suppose if I call this function from somewhere else, and there I write nothing about the class 1. Okay, still it will work, and it will take a class underscore 1 value as this only in this. Okay, while executing this function. Now the second case, if we are calling this function from somewhere and passing the class underscore 1 also, okay, with the different values, let's say 6 and -3. So in this execution it will take a 6 and -3 and not the -4 -1. Okay, so what is this class 1? Is a centroid, I think normally the data will be plotted. Suppose in this space we have to plot the data, so we will take some center point, and then around that we will try to, now around that we can take this cluster, kind of a cluster center, just assumption as an assumption, and then surrounding data how will we plot. So we will add some noise, random noise into that, so that they will get scattered here and there, but not scattered so much. It will scattered such that it will look like some cluster, and we are going to see that very soon. So this is that is the center point for the class 1 and center point for the class 2. Then class 1 variance, because we are adding the noise to the each class, so class 1 datas will get a noise of around 2, variance of the 2. So there could be the addition of the 1.8 or 1.9 or 2.1, 2.3, 2.1. I mean that case, I think 2 will be maximum, because we can see that this class 1 var, if we see this is the class 1 var, is multiplied to the np random dot rand data 1 count. So how many points we want, and this rand function, what it will do, it will generate the number this many times, and every number will be randoms, but will be always in the range of 0 to 1. Okay, so 10 points, 10 values will be generated. Sorry, if the data 1 count is a 10, then 10 values will be generated, array of 10 values will be generated, and each element of that array will be always in between 0 to 1 randomly. Okay, and I don't think, I think there is a need to explain more on the what is a randomness, right? So similarly class 2 variation also. So if there is a class 2 here, so the points will be here only, or it will be in this vicinity, or it will be bigger vicinity. Okay, that will be decided by the variance, right? So maximum value will be 3, and so 0 to 3 it will be, and here it will be 0 to 2, right? When we multiply this value by to the np random data. So class 2 var is here, so this will be the class 2 noise, and then adding this noise to the our these points -4, -1 and 2 and 3. So data 1 is added the class 1d with the class 1 noise, class 2 data with the class 2 noise, and we got a data 2 array. So we got a 2 types of the data, 2 class data, and that will come back here. Okay, so now let me add some more things. Okay, I can go for whole, yes, but we will focus one after the other and not all at a time. So just focus on this centroid one, because once we have a data of the 2 classes, we wanted to find out, because normally the data belongs to which category, it will be given already. Okay, and that's a kind of training process. We will come to that, what is training and testing and all those things, but right now let's think about this. We have a data 1 array and data 2 array, and from data 1 array and data 2 array we got a mean value, average value. Okay, I think these programming steps you can always compare with what we did in a last video, while calculating, that centroid lines and hyperlines, and before that we calculate a midpoint. To calculate midpoint, we calculated centroid points. Centroid points were calculated from the data, two classes data points, and like that. So centroid 1 is calculated from the data 1 array, centroid 2 calculated from the data 2 array. Okay, because this is the mean, and on the axis 1. Now centroid 1 we have, centroid 2 we have, so we will calculate the midpoint of that, and so if we add and divide it by 2, so it is going to be a centroid's midpoint. Now next step was we wanted to have a slope of the centroid line, because slope of the hyperline is nothing but the -1 divided by slope of centroid line. So slope of centroid line, we have a 2 points, centroid 1 and centroid 2. So y2 minus y1 x2 divided by x2 minus x1, we got a slope of centroid line. Now slope of hyperline is nothing but the -1, that is the theorem, minus mathematical theorem, so -1, and it's a proven theorem. -1 divided by slope of centroid line is equal to slope of hyperline. So automatically it will be assigned that slope to the slope of hyperline. Now just to plot the centroid line, we have, just because we have already a ready function, so you can see I just took this one, okay, these instructions, and what we did in a classifier utility, line draw is also mentioned. So you just pass on the slope and y-intercept, and just it will give you the x1 points and x2 points, which you can plot on the graph over here. So we have just collected the xc and yc, that means centroid lines x coordinates and y coordinates, and if we try to plot, I think we will get a one line. We will see that. Then x1 and y1. Now what is this x1 and y1? It may not be off right now at this, and okay, so this is just to show, because x1 and y1, because centroid midpoint we want to show, so just we have put that in a x1 and y1. That's it. Now ch, that means hyperline intercept. So hyperline intercept will be nothing but, what is this ch? What was a xc and yc? Okay, this is the ch. Okay, yeah. So centroid midpoint minus slope of hyperline into centroid midpoint 0. So from the, I think this we have taken from when we draw the slope of this, I think we got this equation. Okay, so we got this equation. So here what will be the slope, because we will have to draw that line, and that is the reason we took. So anyway, how did we get this? I think we have a, oh yes, we got this way, but no, these are the direct values. I think it will be given in the, okay, it will be given in the PPT. We will see that very soon, that how the centroid midpoint, no, not a centroid midpoint, the x1, yeah, ch is calculated. Okay, how the ch is calculated. Oh, I think it is given here. So we have a equation y minus y1 is equal to mx minus x1, and if we expand this, y is equal to mx minus mx1 plus y1. Okay, and then we are trying to bring this standard equation, which is nothing but the slope and point slope standard equation, in a different standard equation, that is y is equal to mx plus c, which is nothing but the slope and y-intercept form. So y is equal to, let us just expand this, and then this will yield y is equal to mx plus c, where the mx, okay, so m is a slope, and this whatever is the rest of the term which is constant, there is no y or x variable in this. Okay, all these are the constants, so this value is going to be our y intercept, right? And that is why if we write this properly, y1 minus mx1 will also do, and that's why c is equal to y1 minus mx1. So when it is a y1 is equal to mx1, that's why ch is nothing but the centroid midpoint 1, okay, and minus slope of hyperline into centroid, that means mx1 point, right? The point which is on that line, and then we have seen that the midpoint is on the midpoint of the two centroids is on the line, so centroid midpoint 0. Okay, so that is how this is ch is calculated. And now xh and y was, so put this slope, we know the slope of hyperline, and we know the y-intercept of our hyperline, and we just give them as inputs, and it will plot, it will give a x and y coordinates of hyperline by this function. Okay, fine. So now we have most of the things, we have decided the hyperplane, hyperline, and now we are going to see those values. So let me take all plotting things. Okay, and let me run this completely. I think this is nothing but the scattered, so we have plotted the data 1 array, okay, and data 2 array. Data 1 array x coordinates, because of this is the 0 and this is 1, so y coordinates 0, data 2 0, x coordinates of data 2, and y coordinates of the data 2, okay, with the red and green color, and we bought a centroid, so you can see the centroid is a green. In this red cluster there is a green, so that is the centroid of this point. Just to highlight that, we have changed that color, and here instead of green we have shown that centroid of this data by a red color. You can see this is red. Okay, so this green line is, that means centroid line is passing through these 2 points, and perpendicular line is coming over here. Okay, perpendicular line is coming over here now, and this is nothing but the hyperline, so automatically this algorithm is deciding. So let me just go back here. Okay, so we just saw the implementation of else, that simple ML algorithm to decide the hyperplane if the data of the two classes are given, and this was a theory in that, and then we made some steps. So let me just reiterate those steps by reading this. Simulate the two class data points. Okay, that's what we did. Calculate two centroid points, each for one class. Line joining about two centroids, let's call it by a centroid line. Determine the midpoint of two centroids, let's have a hyperline perpendicular to centroid line and passing through the above midpoint. Okay, and then hyperline is perpendicular centroid. We know slope of the hyperline is nothing but the -1 divided by slope of centroid line. We know 2 points of centroid line, its slope is going to be 2 by 5, so slope of hyperline is going to be -5 by 2, and then we know the standard point. So okay, so this is we got the hyperline, but we don't need this kind of equation in our programming, because then we won't be able to, we can able to draw, we will able to draw, but only the generalized, because we have already implemented the function which will take a slope and y-intercept as a parameter and will draw the line, and that's why we changed that. I think we have seen that in a comment section of the in a comments put in a Python program, right? So let's see the results. I think we have already seen by running the program, but now I'm just showing this. You can see if because this time the cluster was in the -4 and -1, that means here, and class 2's cluster was a 2 by 3 here. So we got a variance for the class 1 2, and class 2 variance was 3, and then points were 20 and 25. for the class 1 and class 2 respectively. So these are the drawn points. This is the centroid, this is the red centroid, this is join, and then calculated the perpendicular uh, uh, line to the centroid line, which is nothing hyperplane. So in this case, we are just going to change the data. See, now the class -3 -5, just we change the data, same program we run again, and we got. So see, the programmatically we are able to find out the hyper line or hyperplane, this red line. Okay, one more example there could be. So again same thing, 1 minus 1. So you can see these are the somewhat closer, the clusters are closer, and still it is able to do this. Okay, you can see another way, it can be over here, this time the more points 40 and 55, and still it is able to do that. Okay, so so this hyperline is a byproduct of the training which was achieved using the given data points from both classes. This is nothing but actually training phase, because this red line, deciding the red line, okay, from the given data points is nothing but the training phase. And now the hyperline, this hyperline equation can be used for new data points. So in this case, you just now forget, once the hyperline is decided, now you forget about all the points and all data you can discard. And now let there be the new data. Let's say these bigger triangles and bigger circles are the new data now, and let us solve the this equation, hyperline equation, for this point, and then whatever the value after solving that equation we will get for this point, the sign of that will decide whether that point is on this side or this side. Okay, same thing will be done for this one, which is unknown because this was not used in the training while calculating the hyperline. This is also data, this is also data. You can put anywhere here, you can put anywhere here, and then you can calculate, and then it will give you the sign of the solution of that equation will give you whether that point is on this side or that side. Okay, so that's a testing phase. We can say that's a testing phase, right? So that's how we are going to, we are going to have a first training from the given data, and whenever that given data is there, it will have a labels. Labels means the class which it belongs to. So once we have a data and the class which it belongs to, that is also called as a label. So data and labels, if we have for, let's say, 2 classes, then I think we can do the training. In training, it is nothing but the deciding the hyperline. Once we have a hyperline, discard all the training data and all, let there be only hyperline, and now apply unknown points on this line equation, and that it's the solution of that line will tell you that those points are on which side of this line, okay, or which class that point belongs to. And that's what the machine learning with the training and testing. So it is a kind of the supervised training. Okay, let me see. Okay, so that's all for this video. Thank you, thanks for watching.